Right. Yes. Let's get started. Take out your math textbooks. You have this book. Okay. Good. So last class, how many problems did we solve? 3.2 we are done, no? Right. Can you come here? So 3.2, did we complete all the problems? So for 3.3, we directly need to get started with the problems. Okay. 3.3, I would have done 2 problems. Okay. So we will get started with exercise 3.3. Okay. Okay, listen to this. Previous class, I showed you certain basic angles to be remembered in terms of degrees and radians, right? I hope you remember them. So we saw between 0 to pi. So what are the angles? 0 degree corresponds to 0, 30 degrees pi by 6, 45 degrees pi by 4, 60 degrees pi by 3, and 90 is pi by 2, 120 is 2 pi by 3, 135 is 3 pi by 4, 150 is 5 pi by 6, and 180 is pi. Okay. So we'll try to write for the other values as well. After this, what do you have? 210 is there, no? So 210 corresponds to how much angle? Basically 210, nothing. It's very simple. Okay. You don't do that 210 by 316 to pile up. I'll tell you. 210 is how many times 30? 7 pi by 6. That's so 7 times pi by 6. That's what I did there. No, 150 is 5 times 30. So 5 pi by 6. Okay. Similarly, next is going to be 225. 225 is how many times 45? 5 times. So it is going to be 5 pi by 4. Understood? So similarly, you will have 225, then what you have? 60, 240. So 4 pi by 3. Then what will you have? You will have 270. So 270 is, so 90 is, then what you can think of 300. 300 is 5 times 60. 5 times 60, it will be 5 pi by 3. Okay, then you can think of 315. 315 is a multiple of, since 5 is there, it should be a multiple of 45. 6 na last 30 varnalla. It will be 7 times. 6 na 6 5 is 30. So it is 7 pi by 4. Then we can think of, see, whatever number you write, 330. 330 is 11 times pi by 6. So think of it like that, 11 pi by 6. Then you can think of 360. 360 is basically, I hope you're able to understand this, right? So all that I do is I first remember the first 1 to 5 values, and I'll see how many times the multiple is. Just multiply that with the corresponding angle. Is the point clear? Okay. And before we start with 3.3, the next thing that you're supposed to remember is which trigonometric ratios are positive and which trigonometric ratios are negative in a particular quadrant. So in the first quadrant, all. Second quadrant, tan. Fourth, they use some all silver teacups. That's wrong. That's okay. However, you want to remember everything sine, tan, and cos. When I say cos, secant. When I say tan, it is cot. Shall I proceed? You're writing? Yeah. So, இதை மட்டும் ஞாபகம் வச்சுக்கணும். இது வரைக்கும் ஞாபகம் வச்சுக்கன்னா இதுல இருந்து எல்லாமே மல்டிப்ளிகேஷன். ஓகே, கொஞ்சம் டைம் எடுக்கும், but don't worry about it. Shall I proceed? Listen. So I'll just start with the first problem again. So what is the first problem? Can you tell me the question? Okay. Is equal to minus half. Okay. So this is the first problem, and we need to prove that this expression is generating a value of minus. So sine pi by 6 the whole square plus cos pi by 3 the whole square minus tan pi by 4 the whole square. So what is sine pi by 6? Sine 30 is a half. So half square plus what is cos pi by 3? It is also half square minus what is tan pi by 4? 1 square. So 1 by 4 plus 1 by 4 minus 1. So half minus 1 is going to be minus half. Right? So to put it simple, these problems you have seen last year also. But only difference is here it is in terms of radian, there it was in degree. That's here. Shall I proceed? Rohit. So second. What is the second problem? 2 sine square the whole multiplier is equal to 3r. Okay. So the question is 2 sine square pi by 6 plus cosecant square 7 pi by 6 multiplied with cos square pi by 3 is equal to 3 by 2. So again, we'll take LHS into consideration. So 2 is written as it is into what is sine pi by 6 value? Sine pi by 6 is half, and you need to write the square of it, plus cosecant square 7 pi by 6. So observe, cosecant 7 pi by 6 can be written as, so you can basically be written as cosecant of pi plus pi by 6. So pi plus pi by 6 means which quadrant are you entering into? You are entering into third quadrant. So third quadrant cosecant is negative. So minus cosecant pi by 6. See, cosecant pi by 6 is 2. Because sine pi by 6 is half, cosecant pi by 6 will be 2. And this is going to be minus 2. So here what you should do is, it will be minus 2 the whole square. Into cos pi by 3 is known to us. It is half, and you have a square here. Okay. So 2 into 1 by 4 plus 4 into 1 by 4. So 4 and 4 will get cancelled. This will cancel this 2 times. Half plus 1 is going to be 3 by 2. So those who understood the concept, don't wait for me, please proceed. Question படிக்கிறியா எனக்கு? 1 minute. Cot square. Okay. Cosecant. Okay. Cosecant 5 pi by 6. Sir. Okay. Plus 3 tan square pi by 6. Sir. Okay. Is equal to. Okay. So the next problem is cot square pi by 6 plus cosecant 5 pi by 6 plus 3 tan square pi by 6 is equal to 6. So if I take the LHS into consideration, cot square pi by 6, right? So it is root 3 square plus cosecant 5 pi by 6. Since it is greater than pi, let's derive and see. Sorry, since it is greater than pi by 2, let's derive the value and see. So cosecant of pi minus pi by 6. So cosecant pi minus, so pi minus means you're following the second quadrant. In second quadrant, cosecant is positive. So you write this as cosecant pi by 6. You know that sine pi by 6 is half. Cosecant pi by 6 will be 2. So here it will be 2 plus 3 into tan pi by 6 is 1 by root 3. So you have 1 by root 3 the whole square. So you have 3 plus 2 plus 3 into 1 by root 3, the whole square is 1 by 3. 3 and 3 will get cancelled. 3 plus 2 is 5. 5 plus 1 is 6. Here. Next. Akhil, read the fourth question. Two sine square. Okay. No plus or minus. Plus. Okay. Okay. 10. Okay. So this question is 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3 is equal to 10. So if you take the LHS into consideration, 2 times sine 3 pi by 4 the whole square, right? Plus 2 into what is cos pi by 4 value? It is 1 by root 2. You have a square here. Plus 2 into what is secant pi by 3 value? Secant pi by 3 value is 2. So it is going to be 2 square. Because secant pi by 3 is 1 by cos pi by 3. Right? So sine 3 pi by 4 alone, I'll do the work here. So sine 3 pi by 4 is equal to sine of pi minus pi by 4. Which quadrant again? Second quadrant. So when it is second quadrant, it is going to be sine pi by 4 itself, which is 1 by root 2. So take this value and substitute it here. So 2 into 1 by root 2 the whole square plus 2 into half plus 2 into 4. So 2 into 1 by root 2 the whole square is half plus this 2 and 2 will get cancelled, which will be a 1 plus 8. So here also 2 and 2 are gone. So 8 plus 1 is going to give us 10. Yeah. So I hope it is simple, no? Shall I proceed to the next one? So what is the fifth question? Sorry? So find the value of sine 75 degree, right? So you cannot find it, I'll tell you. So from now, we need to get back to theory. I want everybody to concentrate. Listen to this. So till now, whatever problems we solved were basically finding the trigonometric ratios of known angles. For example, 30, 45, 60 or 90, or they were multiples of those values. That is why we could solve it easily, right? But there are certain scenarios where the angle will not be known to us. But that angle can be written as sum or difference of two known angles. For example, if I have this 75, I can write it as sum of 45 plus 30. So if I take this to be A and this to be B, if I take this to be C, can I say sine C is equal to sine of A plus B? Can I say that? Means sine 75 is obtained by me doing an operation of sine of 45 plus 30. So this A plus B is what is called as compound angle. Okay. So now our job is to understand how to deal with these compound angles. Okay. Am I clear with this? Right. So the heading is going to be trigonometric ratios for compound angles. Okay. So the first one obviously will start with sine. So when I say sine of A plus B, this is written as sine A cos B plus cos A sine B. So I'm not getting into the derivation of this, but this is how it is written. Okay. This can be proved in multiple ways. You can use trigonometry to prove this. You can use vectors to prove this. You can do it. So when time permits, I'll explain. Okay. But as of now, proof is not the main point here. Secondly, if I want sine of A minus B, it is given as sine A cos B minus cos A sine B. Sine A cos B minus cos A sine B. Similarly, if I look at what is cos of A plus B, it will be cos A cos B. Remember, when you have a plus here, cos A cos B, you will have a minus here, unlike sine. See, for sine, what is happening? Plus and a plus, minus and a minus. Whereas for cos, if you have a plus here, here you will have a minus. So similarly, if I look at the fifth one, if I write cos of A minus B, it is going to be cos A cos B plus sine A sine B. So all that you need to remember is, whenever you're doing the sine of a compound angle, the combination will be sine cos plus cos sine. When I say sine cos, I'm taking sine of first angle A, cos of second angle, plus when I say cos sine, order is very important here. Okay. So then it will be cos A sine B. Why order is important is, in this case, it is fine. If you write it in the reverse also, it is okay. Whereas in the second case, instead of sine cos minus cos sine, you cannot write it as cos sine minus sine cos. You should not change the order. Is the point clear? Are you able to understand with respect to sine? Similarly, when it comes to cos, it will be cos into cos, the opposite sign. Cos into cos minus sine into sine. If it is cos of A minus B, it will be cos into cos plus sine into sine. Okay. So these four formulae are supposed to be remembered, and they are very, very important. So based on this, I'll show you the derivation for the remaining formulae. Okay. So make a note of this. Sorry, டீ குடிக்கிறேன். ஓகே, யாருக்காவது வேணுமா? வேணாமா? கொடுத்தா குடிப்பேன்ற கரெக்டா? ஆனா இல்ல, சாரி. Next time maybe. Okay, shall we get started? So these four formulas, I hope it is registered in your mind. From next slide, I'm not going to show. I'll ask you. Is it registered? Yes, good. So now we'll start with the fifth one, which is tan of a plus b. Right? So for tan of a plus b, you do not have a ready-made formula like that. So what we are going to do is we'll derive it. But yeah, we'll be remembering the result at the end. So it is sine of a plus b divided by cos of a plus b. Right? So sine of a plus b is sine a cos b plus cos a sin b divided by cos of a plus b is cos a cos b minus sin a sin b. Right? See, what I want is when I look at sine, right, it is a combination of sine and cos. Similarly, when I look at cos of a plus b, it is a combination of cos and sine. But what we will do is tan will convert it as a function of tan itself. Means I don't want sine or cos to exist. I want only tan to exist. For that, what I'll do is I'll multiply and divide with cos. Okay, but the question is, what value of cos am I supposed to divide with? Because I have a and b. So listen to this carefully. I'll divide it with the highest number of cos I'm able to find in this expression, which is cos a into cos b. The logic is very simple. Why I'm doing is because sine by cos will give me tan. That is the only logic. Okay, so I will multiply and divide it with cos a cos b. So when I do this, I'll have sin a cos b plus cos a sin b, the whole divided by cos a cos b, the whole divided by cos a cos b minus sin a sin b divided by cos a cos b. See, this is what is multiplying and dividing. Okay, this will actually be in the numerator, that I brought it to the denominator just to save one step. Now what I'll do is I'll split this cos a cos b to each term. When I do this, I'll have sin a. Observe this. When I write sin a cos b, what will I write? Okay, I'll write this step. Listen, sin a cos b divided by cos a cos b plus cos a sin b divided by cos a cos b, the whole divided by cos a cos b divided by cos a cos b minus sin a sin b divided by cos a cos b. Okay, so cos b and cos b are gone. Cos a and cos a are gone. Cos a cos b into cos a cos are gone. Similarly, here nothing is lost. Okay, so sin a divided by cos a, tan a minus sin b divided by cos b, tan b, the whole divided by, this is 1 minus sin a by cos a is tan a, sin b by cos b is tan b, and this is the expression. Sorry, yeah, tan a plus tan b by 1 minus tan a tan. So this is the expression we need to remember. Am I clear with this? Please make a note of it. See, just a point. In your textbook, instead of a and b, they gave it as x and y. They both are same. Because wherever sign is there, think of this, remember this in mind. Wherever sign is there and you're expected to write it in terms of tan, all that you need to do is divide and multiply with cos. Because each term in the expression is multiplied twice. It's a combination of sine and cos and sine. So like that, if you see where is maximum cos available, yeah, we have to do cos only because I want the sine A to get converted to tan A. I thought of only one that thing, but what happened is cos B got cancelled. சார்ஜர் இங்க என்னோட அது இல்ல மேக் சார்ஜ் அங்க பின்னாடி இருக்கு மேக். Done with this? Yeah. So next thing is, so the sixth identity is tan of A minus B. So when you do this tan of A minus B, sure. Yeah. Okay. Proceed. So next one is tan of A minus B. So we know that tan of A plus B generated tan A plus tan B by 1 minus tan A tan B, right? So all that you need to do is replace the plus with minus and the minus with plus, meaning this will be tan A minus tan B the whole divided by 1 plus tan A tan B. Which one? No? This one. No, it is C. Because see, I'll tell you the logic. How will you start the derivation? Let's not write it, but let's think logically. You'll write sine by cos. So denominator, what do you have? You have cos A, cos B. Sorry, you have cos of A minus B. So when you have minus sign for cos, how will the output come out as? Cos A, cos B? No, cos of A minus B is cos A, cos B plus sin A, sin B. That is. Similarly, with the numerator, what do you have? Sin A cos B minus cos A sin B. That is this minus. Understood? Okay. So the proof is similar. So that's why I'm not showing it to you. Okay. Next one is 1 minute. Huh? So the next one, this previous was sixth one, no? Yeah. So the seventh one is cot of a plus b. Okay. See, cot of a plus b is going to be cos of a plus b, the whole divided by sine of a plus b. Right. It is going to be cos a cos b minus sin a sin b, the whole divided by sin a cos b plus cos a sin b. Right. So logic is very simple again. Listen to this carefully. Thing is, when we wanted tan of a plus b, we wanted the final output be in terms of tan. Similarly, when you want cot of a plus b, the final output should be in terms of cot. So whenever you have cos and sine, when you need to get cot, what are you supposed to do? Divide by sine. So what we will do is divide the numerator and denominator with sin A, sin B. I need maximum number of sines. So when I do this, what I'll get is cos A cos B minus sin A sin B, the whole divided by sin A sin B. This whole thing divided by sin A cos B plus cos A sin B, the whole divided by sin A sin B. Right. So this will be equal to cos A cos B, the whole divided by sin A sin B minus sin A sin B, the whole divided by sin A sin B divided by sin A cos B divided by sin A sin B plus cos A sin B divided by sin A sin B. Listen to this. So here there is nothing that will get cancelled. So cos A by sin A is going to give us cot A. Cos B by sin B is going to give us cot B minus sin A by sin A into sin B divided by sin A into sin B gets cancelled, minus 1, the whole divided by sin A and sin A. So it's going to be cot B plus, here sin B and sin B are gone, it is going to be cot A. So this is going to be the final expression. So it is cot A cot B minus 1 divided by cot B plus cot A, or cot A plus cot B also. Okay. And one more point to mention, see, whatever logics I'm giving you here, it's not only for the derivation purpose, this logic can be used to solve most of the problems as well. Okay, so so give me a confirmation, are you able to understand why I'm thinking like this? It will be cot B minus 1. No, see, x plus y, in this case, I'm telling us. But generally, it is better you remember it like this. You can remember as B comes first and A comes next. Okay. So are you clear with this? Right. Now, see, one point I always keep telling is never solve a trigonometry problem using only one method. Don't restrict yourself only to one logic. Okay. When that is the case, for the same cot of A plus B, if I think of an alternate method, I wrote it as cos by sin. No. Instead, can I directly write it as 1 by tan of A plus B? I could have written it. So 1 by tan A plus B means, see, tan of A plus B is tan A plus tan B by 1 minus tan A tan B. Okay, so it will be the reciprocal of it. 1 minus tan A tan B, the whole divided by, I hope it makes sense. But since I want everything in terms of cot, what I'll do is I'll write every tan in terms of cot. When I do that, I get 1 minus 1 by cot A cot B by 1 by cot A plus 1 by cot B. So cross multiply and take LCM. So in the numerator, you will have cot A cot B minus 1 divided by cot A cot B, the whole divided by cot B plus cot A, the whole divided by cot A cot B. Gone, and there's the final expression. So it will be cot A cot B minus 1 divided by cot B plus cot A. Got it? Those who are online are able to understand?
Yes, sir.
Very good. If there is any doubt, please stop me, okay? Sure. Should I proceed? Shall I proceed? Is that doubt? Right. So similarly, 8-1. When we think of cot of A minus B, you will get the same thing. You will get a similar kind of thing, right? But what will happen? You will have cot A, cot B, cot A, cot B plus 1. But this is where we need to be very careful. In the previous case, I told you cot A, see cot B plus cot A can also be written as cot A plus cot B. But here you can't interchange the order. It will only be. Why is it so? Because you write this as cos by sine, right? So when you write sine of A minus B, there'll be a minus sign there. And because of that minus sign, when you cancel it, they're always getting interchanged. Means A is getting cancelled first, B is getting cancelled second. So you need to observe all these things. You're able to understand what I'm saying. A got cancelled first, then B got cancelled. Okay, so that is why B will be left out first. So B is left out first and A is left out next. Okay. So for this, I'm not showing the proof. It's a similar kind. Okay, you can use both the methods to solve it. Okay. Shall I proceed? Right. So this is all about dealing with trigonometric ratios and compound angles. We'll not see for secant, cosecant, and all. Because whenever we need those values, we can find the sine and cos of those values. Right. Next. If you observe, we have the multiples of angle. So we are going to see the trigonometric ratios for multiples of angle. For example, if I want sine 120 degrees, right? Can I write this as sine of 2 into 60 degrees? So if I have a direct formula where I'm able to relate that sine 120 in terms of sine 60, I'll be able to solve the problem faster. Right? So that is why we need to start developing some formulae for the multiples of angles as well. So I'll show you. So I'm rubbing that part. This anyway you will understand after I complete it. Okay. So now what I'm going to do is, first, I'll start with sine of 2a, like how I gave you there. Sine 120, you can write it as sine of 2 into 60. Right. So sine 2a, can I write it as sine of a plus a itself? So what is sine of a plus b? It is going to be sine a cos a. Basically, it is sine a cos b plus cos a sine b. What is b? B is also a only. So what is this basically? Sine a into cos a plus sine a into cos a. It is 2 times sine a into cos a. This is the expression for sine 2a. Okay. But we are not going to stop with this. I'll give you another expression also. Okay. So this is one. This 2 sine a cos a is there, no? I will try to represent this in terms of tan. So what I need to do? Logic is simple. So whenever you have sine, you need tan, divide and multiply it with cos. So 2 times sine a into cos a divided by cos a into cos a. Makes sense? Now I'll combine these two. I get 2 tan a. Cos a into cos a, I'll get cos square a in the numerator. So cos square a can also be written as 1 by secant square a. Cos square a is the same as 1 by secant square a, because cos a and secant a are reciprocal of each other. Am I clear with this? So this will be equal to 2 tan a divided by secant square is 1 plus tan square a. So you can write it as 1 plus tan square a. This is another expression. Meaning sine 2a is either 2 sine a into cos a, or it is also equal to 2 tan a divided by 1 plus tan square a. So let me write an extra step. So sine 2a is basically 2 sine a into cos a, or it is also equal to 2 tan a divided by 1 plus tan square a. Clear with this? You are expected to remember this. Okay, 2 sine a cos a mostly we'll use this year. 2 tan a by 1 plus tan square a is used next year a lot. In your 12th grade, you'll use it in chapters named inverse trigonometric functions. You'll use it in your calculus. So at that time, I've seen many of them struggling, not understanding this. I'll tell you why they don't understand also. After I derive for tan 2a, you'll understand where the confusion will start. Okay, but I want you to be clear with it. Is the derivation clear? Right? So I would suggest don't look at the board, do it on your own. Only if you have a doubt, look at the board. Clear? They start this chapter in your school. Did any school, like your school, did they start this? Relations and functions they have to start. Done? Shall I proceed? Yes. Right. Okay. Next question. We are going to see for cos 2a. So cos 2a can be written as cos of a plus a. Okay. So this is going to be equal to cos a into cos a minus sin a into sin a. So cos a into cos a is cos square a minus sin a into sin a is sin square a. This is the formula. Okay. So sin a into sin a is sin square a. This is one formula. You can do an OR here by leaving cos square a as it is and writing sin square a as 1 minus cos square a. When you do this, you get cos square a minus 1 minus of minus is going to be a plus cos square a. So it is going to be 2 cos square a minus 1. So basically, it can either be written as cos square a minus sin square a, or it can be written as 2 cos square a minus 1, or right, cos square a you can write it as 1 minus sin square a minus sin square a. So this will be 1 minus of 2 times sin square a. So either of them is accepted. So depending on the problem, you will be using the required formula. Okay. But there is a fourth one also. Right. So how it happens is it is cos square a minus sin square a. We'll try to completely write this in terms of tan. So if I have to write this in terms of tan, again the same logic, multiply and divide it with cos square a. Right. So cos square a by cos square a, 1. Sin square a by cos square a minus tan square a into cos square a can be written as 1 by secant square a. So it will be 1 minus tan square a divided by 1 plus tan square a. So this is one formula. This is another one. This is the third one. And this is the fourth one. So cos 2a alone has 4 different ways of expressing. Okay. And it is the most important of all, because this formula can be manipulated and you can convert it into many other identities as well. Are you able to understand? So that is why I would suggest cos 2a is very, very, very important for you to remember. Done? Shall I proceed? I'm just giving you some time to absorb. Is it going in? You should remember next time onwards, right? So I have only one wish. I don't want you to look at your, whenever a problem comes, you should not turn your page and do it. You should on spot start doing it. That is why whenever you're doing it, no, concentrate, observe what are the differences and get it into your mind. I'm telling you, trigonometry for most of them is a nightmare, especially these kind of foreign and all, they will get scared. But there is nothing. Okay, it's all about logic only. You need to understand where to apply which identity, right? So third, tan 2a. This can be written as tan of a plus a, right? So this will be equal to tan a plus tan a by 1 minus tan a into tan a. So tan a plus tan a is going to give you 2 tan a by 1 minus tan square a. See, this is where I want you to concentrate. There is a similar expression for another identity. 2 tan a by 1 plus tan square a, whereas here it is 2 tan a by 1 minus tan square a. I told you, people get confused. There is the reason. They just don't observe where plus will come and where minus will. Minus will come for tan because if you recollect the derivation, it is only 3 steps. Not even 3 steps. We finished it in 1. Right? What is that we did? Whenever you want tan 2a, what is that you're going to do? You'll write it as tan of a plus a. Whenever it is x plus y, what is the denominator? 1 minus. So you should remember that minus, so that you'll not have that confusion. Okay. This one and the other one are similar. For sin 2a, you have a plus in the denominator, whereas for tan 2a, you have minus in the denominator. Okay. Yeah. See, cot 2a and all generally we don't apply because cot 2a is needed. You'll find tan 2a, take the reciprocal, you're done. So if at all you need, what will be the formula? Can you do it in mind and tell me? Cot 2a, recollect, cot 2a, what is that? Cot a into cot b minus 1 by cot b plus cot a. So replace b with a. What will you get? Concentrate, you will be able to get it. You people are not concentrating. Cot square a minus 1 by 2 cot a. You get cot square a minus 1 by 2 cot a. Okay. That's anyways not considered as the identity. Only these 3 are taken into consideration. So I hope this part is clear, right? So the next one is sin 3a. So this is also an identity. You need to remember. When it crosses 3, all you need to do is in the problem you will manipulate it. Okay. So you will remember sin 2a. Sorry, first sin a plus b, sin 2a, and sin 3a. These are the identities you need to remember. So sin 3a, you can write it as 2a plus a. Right. So sin 2a is going to be, sorry, sin of 2a plus a is going to be sin 2a cos a plus cos 2a sin a. Right. So sin 2a, in terms of sin, there is only one identity. What is it? It's 2 times sin a into cos a. This whole thing multiplied with cos a plus. For cos 2a, there are 4 identities, right? Among the 4, first one is cos square minus sin square. Second one is 2 cos square minus 1. Third one is 1 minus 2 sin square. So what I'm going to do here is sin 3a, I'll completely try to express it in terms of sin only. So for that, from cos a, I'm going to use the identity 1 minus 2 sin square. I'll use 1 minus 2 sine square A into sine A. Make sense? Yes. So it is going to be 2 sine A into cos A is cos square A, right? So cos square A, I can write it as 1 minus sine square A. I repeat, cos A into cos A is cos square A. Cos square A is written as 1 minus sine square A plus the sine A will get multiplied with each term. You'll have sine A minus 2 sine cube A. Okay, so this will be 2 sine A minus 2 sine cube A plus sine A minus 2 sine cube A. Okay, so 2 sine A plus sine A is going to give me 3 sine A minus 2 sine cube A minus 2 sine cube A is minus 4 sine cube A. And this is the expression for sine 3A. There is only one expression. And this is expected to be remembered. It is 3 sine minus 4 sine cube. So you can remember it like this. 3s minus 4 s cube. Okay. So make a note of this. So let me know once you're done. Completed? Shall I proceed? Okay. Those are online completed?
Yes, sir.
Okay.
Yes, sir.
So look at the fifth one. It will be cos 3a. So cos 3a is going to be cos of 2a plus a, which will be cos 2a into cos a minus sin 2a into sin a. So wherever cos 2a comes, be careful. Okay. So since you are writing for cos, express cos 2a in terms of cos itself. So for that, I will use the identity 2 cos square a minus 1 into you have cos a minus sin 2a can be written as 2 sin a into cos a, the whole multiplied with sin a, right? So when you multiply it here, it will be 2 cos cube a minus cos a minus 2 sin a into sin a is 2 sin square a into cos a. Okay. So this will be 2 cos cube a minus cos a minus 2 into sin square a will be 1 minus cos square a into cos a. So this will be 2 cos cube a minus cos a minus, observe, 2 into 1 into cos a. It is 2 cos a. Minus of minus is plus. 2 into cos square a into cos a is 2 cos cube a. Now combine the terms. So 2 cos cube a into 2 cos cube a will be 4 times cos cube a minus cos a minus 2 cos a will be minus 3 cos a. So this is going to be the expression for cos 3a. If you observe, it is exactly the reverse of what you observed in sine. So it is 4 c cube minus 3c. There it was 3s minus 4s cube, right? It is exactly the reverse. So the next one is going to be for tan 3a. So tan 3a is going to be equal to tan of 2a plus a, right? So tan of 2a plus a can be written as tan 2a plus tan a, the whole divided by 1 minus tan 2a into tan a, right? Tan a plus tan b by 1 minus tan a tan b. So directly take the formula for tan 2a and substitute it there. It is going to be 2 tan a divided by 1 minus tan square a plus tan a, the whole divided by 1 minus 2 tan a by 1 minus tan square a multiplied with tan a. Clear with this? So observe. All that we need to do is take LCM. So it is going to be 2 tan a plus tan a into 1 minus tan square a. So it is going to be tan a minus tan cube a basically. Just to explain it again, this tan a is getting multiplied with each term. Tan a into 1 minus tan a into tan square a. That's what I wrote it there. The whole divided by 1 minus tan square a, this whole thing divided by, if you observe, 1 minus tan square a is getting multiplied with 1. So you will write it as it is, 1 minus tan square a minus 2 tan a into tan a minus 2 tan square a, the whole divided by 1 minus tan square a. So 1 minus tan square a and 1 minus tan square a are gone. So 2 tan a plus tan a is going to be equal to 3 tan a minus tan cube a, the whole divided by 1. See, minus tan square a minus 2 tan square a is minus 3 tan square a. So 1 minus 3 tan square a. And this is going to be the expression for tan 3a. So it is basically 3t minus t cube by 1 minus 3 t square. 3t minus t cube by 1 minus 3 t square. Clear? Trust me, in the next 2 months, it will become very simple. See, now you are seeing so many formulae, right? Just work on this. In 1 month itself, it will become very simple. And I repeat it, it is very, very, very important for next year. You need to remember every expression. புரியுதா? Shall I proceed? Everybody? Yeah. So we'll see the next set. Okay, we have 4 more. The set is sin A plus sin B. So there is a small difference that you need to have in mind. The first one was sin of A plus B. Here it is sin A plus sin B, meaning sin 30 degrees plus sin 60 degree is not the same as sin 90. Right. So let's do and see. What is sin 30? Sin 60. Right. What is sin 90? So you add these two and see. Is it coming out to be, it will come out as 1 plus root 3 by 2. Right. That is one common mistake that happens again. Okay. So as I told, the next set that we are going to see is sin A plus sin B. Okay. I'll do one thing just to avoid the confusion. I'll not use A and B, I'll use C and D. Okay. I'll tell you why I'm doing that. So I'll say sin C plus sin D, where what I'm going to do here is I will say C is equal to A plus B. I'm just substituting C is equal to A plus B and D is equal to A minus B. Okay. So if I take that and substitute it here, what I get is sin of A plus B plus sin of A minus B. Am I clear with this? Okay. So what I did is basically I wrote C as sum of two angles, D as difference of two angles. Then I just took those values, put it here. So when I write sin of A plus B, it is going to be sin A cos B plus cos A sin B. Plus sin of A minus B is going to be sin A cos B minus cos A sin B. If you observe, cos A sin B and cos A sin B will get cancelled. Right. So you have sin A cos B plus sin A cos B, which will sum up to give you 2 times sin A cos B. So it will be 2 times sin A cos B. But the question says C and D. I should not have A and B here. So I need to bring back the C and D. For that, what I'll do is, if I add these two, A plus B plus A minus B, I'll get C plus D. So if I add these two, A plus B plus A minus B, I'll get C plus D. So what will get cancelled? B and B are gone. 2A is equal to C plus D. So A will be equal to C plus D by 2. Similarly, if I subtract these two, right? If I subtract these two in the sense A plus B minus of A minus B, I get C minus D. So A and A are gone. 2B will be equal to C minus D. B will be equal to C minus D divided by 2. So take these two values and plug it here. Answer will be 2 sin of A plus B, sorry. C plus D divided by 2 into cos of C minus D divided by 2. Is it clear? So you get 2 sine of c plus d divided by 2 cos of c minus d divided by 2. And this is going to be the expression for sine c plus sine d. Okay. So I just want to tell you one point. Whenever we have sum of the trigonometric ratios, all we do is we take c as a plus b, we take d as a minus b, and then start. Let it be. You need not worry. You need not worry about it because you will not use this formula in those kind of problems. So not all the problems are going to be only about finding the trigonometric ratio. Some problems will require you to prove that this identity is right. At that point, we'll use it as a tool. Is that a? I'll derive one more identity. Okay. After that, you have 2 more. But before I end the session, I just wanted to tell this. Since these expressions, I would call it, I'll not call them as formulae. Since these expressions are very important for you to remember, I want you to practice it today itself. And for them to get registered in mind, tomorrow, I want you to write a test of all the derivations which I taught today, starting from compound angles, starting from sine of a plus b till this. Okay. So practice it today itself. Okay. As I told you, that is my wish that you don't look at formula while solving problems. Okay. Second, sine c minus sine d. Okay. Again, you will take c to be a plus b. You will take d to be a minus b. Actually, this identity came from the reverse order. Since we know sine of a plus b and sine of a minus b, what will happen if you add them and subtract them? That is the meaning. Okay. So here what is going to happen? You will have sine of a plus b minus sine of a minus b. So it will be 2 sine a cos b plus, sorry, I directly wrote the answer. So it will be sine a cos b plus cos a sine b minus sin a cos b plus cos a sin b. Clear with this? So what will get cancelled? Sin a cos b and sin a cos b are gone. So you have a minus here, right? So sin a cos b and sin a cos b get cancelled. So what is that you're left out with? You will have cos a sin b minus of minuses plus. So you have 2 cos a sin b, right? But we know that when c is equal to a plus b and d is equal to a minus b, when solving these two equations, we get c is equal to a plus b by 2. Sorry, you will get a is equal to c plus b. Yeah, you will get a is equal to c plus d by 2. Yeah, we get A is equal to C plus D by 2 and B is equal to C minus D by 2. Take these values, substitute it here. So this will be equal to 2 cos of C plus D divided by 2 sine of C minus D divided by 2. Here. So just to tell you the difference, observe. When you have sine C plus sine D, it will be 2 sine cos. So when I say sine cos, I'm following an order. Sine will have a bigger angle, cos will have a smaller angle. How did I say which is bigger and which is smaller? Obviously, sum is bigger, difference is smaller. So having the same thing in mind, when you have sine C minus sine D, you will have 2 cos sine. Cos of bigger angle, sine of smaller angle. That order is important. Okay. So this is the expression for sine C minus sine D. Write it down. Your pencil, huh? Okay. Here. Done. So 2 more identities we'll see tomorrow and then we'll start the problems. But first half an hour, I'll give you time to write the test. So don't come here and prepare. Prepare at home and okay. So that's it for today. I'll see you guys tomorrow. So those are online, any doubt?
No, sir.
No, sir.
Sir, could you tell the portions for the test?
Sorry,
Could you tell the portions for the test?
tomorrow.
Yeah.
Yeah, it is from the compound angle, that is sine of A plus B till this one, the one which I got.
Okay, sir.
I'll tell you, if you want, you can see. Basically, yeah. Basically from this slide, yeah, 1 minute. Basically from this slide till this slide. Ananya, got it?
Yes, sir. Thank you.
Okay, done. Yeah, form under, you fill the topics, sir. Who's writing the topics there in the book? You're writing. Okay. Now, yeah. Which one? I didn't think of marks in that. I wanted to see the parent.